everyone, welcome back to Dragonfly Engineering. So this week we've got a little bit of trouble that we got to deal with. One of the polycarbonate molds broke all of its ejector pins. And this is due to me switching the mold from the original molding machine that I used to develop the profile of the injection pressure and everything. Anyway, I moved that mold to the smaller molding machine, which happens to have a smaller injection unit. And that means that there is more pressure imparted in the mold for the same kind of hydraulic settings. So what happened is I filled the mold with plastic and the pressure was a little bit too high. So when the molding machine attempted to eject the polycarbonate part out of the mold, all of the ejector pins broke. So let's go over and take a look so I can show you what I'm talking about. So today we're going to actually fix that mold and get the green robot to run those parts automatically as well. All right, so we can check out the situation here with this mold. I've got the GoPro here. You can see how we've got this polycarbonate part stuck in the B side of the mold. That's the A side. Then if we look down behind the ejector plate, you can see we got all these busted ejector pins. Now these ejector pins are straight shank. There's other ejector pins that have a larger diameter base to help support themselves in the region of travel behind the B side of the mold. So we're going to replace these 1/16 or 1.6 millimeter diameter ejector pins that are straight shanked with necked or reduced shank. So the back of the ejector pin is going to be 1/8 of an inch in diameter, or 3.2 millimeters, up to about here, and then it will reduce down to the final ejector pin size to go through the B side of the mold. So that is our task today. After we get this mold fixed with the new pins, we'll load it back in the molding machine, and then we will continue to teach Green here how to pull the parts out with its end effector and clip off the runner over here on our homemade clipper that we made a few weeks ago. So let's do it. Okay, so we're over on the workbench here. You can see our issues in a little more detail. Let me get this GoPro going again. So there's one thing I can fix off the bat is these 1/8 inch spacers that we have. That I don't recall why I have those other than maybe I didn't want to regrind all the pins. But you can see they're all broken in there. And we've got the part, the offending part that was overpacked, still stuck in the mold cavity itself. So one of the first things we should do is spray a little mold release on this guy and hope that it will start to seep in between the gap between the plastic and the metal, which is unlikely because it's packed in so hard that obviously it broke the ejector pins. But you know, maybe we'll get a little bit of penetration. So I've got some Stoner rocket release mold release here, which I get at Tap Plastic. Those on the West Coast probably know what Tap Plastic is. So let me spray a little bit of this stuff in here. I don't know how well it penetrates, but you know, let's just see what we can get. We may be able to see it through the polycarbonate. I don't know. So we'll let that soak a little bit. I'm thinking one trick that we can do is actually use this part that's stuck in the cavity with the broken off pins. If we can pull them all out from the back, we can use this part as a gauge to set the length of our new ejector pins, because it may be hard to get the exact dimensions of these pins since they're all broken and kind of neck down and bent and everything, but we'll see how it works out. Oh, and actually this mold was done or modified a few episodes ago. I think it was the mold mod. So anyway, we're gonna fix her up here. That's what this steel pin is at the top. This was a core that we added to the profile of the plastic in the inside. Well, these weren't on very hard either. I got these for Christmas from my folks. A Zoom Christmas. So I'll stick this thing in like that. there's all the broken pins. The only pin that didn't break was the sprue ejector. So it'd be hard to see that this would break. So if we pull these out, oh yeah, well, at least they're all going to come straight out. I heard one of the pins actually break off in two pieces, which I believe is this one right here. So grab that one with my fingernails. Or we can use this. There we go. All right. I may spray some mold release in the back of these holes as well. That'll help with the potentially capillary action of the mold release on this part. And then over here is our ejector plate, which needs to be unscrewed now. Wish I had the screwdriver version of this hex key. And again, this is a kind of a quick prototyping mold. So tricks like this spacer, instead of pocketing for the feet of the ejector pin, were used. But I probably should have known better not to use the straight shank ejector pins, but use the stepped ejector pins, which I have an example. Yeah, actually, here's some right here. So these are the pins that we're going to replace with. So this big fat area in the back will bridge the gap from that open area of travel for the ejector plate. I can show you more in a second. Okay. So here's all our offending ejector pins. Here we go. Here's your problem. Okay, so now we got to figure out what length. So because we still have the part stuck in the mold cavity. So one thought is to stick our new ejector pins in, and I can see how it's actually bottoming out against the part there. Maybe hard to see on the camera. And then measure the height of our plate plus the back plate of our ejector plate itself, you know, and basically measure the distance from the plate to the bottom of the mold block, which is the same as this plane and this plane. They join together, and basically subtract the difference, and that may be the easiest thing to do. Now there are two heights for this part. One ring of ejector pins, which are this height, and then another ring of ejector pins, which are this height here. And all of these witness marks for the ejector pins are actually hidden in the final product. And these were actually slightly too short because I get little plastic posts that stick up. I did also, add these spacers as well, which are not ideal at all. They're kind of funky. So we can fix that by subtracting this height as well. So let's do that. I think the next step is to measure the height of this ejector pin as it's pushing against the most ideal hole. And I think I will also subtract maybe 0.010 of an inch or 250 microns to fix the subtle witness mark of the ejector pin that we see here. Then I will subtract the difference of the two ideal positions from this flange height down to the inner flange height, this inner circle, and we will just do some math to optimize these ejector pins. .93. 63.39. And this is a super basic grinder, basically like a big box store grinder. And I'm gonna do the quick and dirty way of grinding these pins. And again, this is prototyping, so it doesn't need to be exactly perfect. Yeah, there we go. All right, so I got the heat gun kind of keeping some heat on this part, and you can see how there's some steam bubbles that have formed in the polycarbonate from it basically softly remelting. I am going to try to just pull it straight out using this these vice grip pliers and grab the freed up or the proud portion of the plastic part here and hope for the best. Let's see if we can maybe just give it a quick pull and yank it out. Oh, I'm seeing some movement. That's good. So I guess all that heat and mold release finally pulled the part out. So that was actually a lot easier than I expected. So that's great to see. All right, now that we got this out, we can test our first ejector pin height and make sure that we're good. Okay, so this thing's still a little warm. I put our new pin in. And again, this is just to test two things, which I just actually confirmed. One is that these holes are bigger than 1/8 of an inch. Yeah, so the fact that, you know, the shoulder portion of our ejector pin can actually fit into that hole and keep traveling is one thing that we needed to confirm over the straight shank ejector pins that we were using. So that's good. That means that we will not jam up in there with the bigger shoulder. We'll stick our pin inside. Whew, hot, hot, hot. Yeah, you can see this pin stuck out. So now when I push that guy down, it ideally should be flush to the top. I may need to get the GoPro. Let me see if I can reach under there and advance it up so you can see which one. So there's the pin pushed up and then down to its final position. I think we are flush, so that's good. I will do the same process for the other 6, and then probably using the CAD model, calculate the height of the inner 6 ejector pins as well. Okay, we're going to use this depth gauge here to figure out what height we need to adjust for the second set of ejector pins for this center circle. We're looking at 120 thousandths of an inch, so that needs to be the difference in height. So the inner ejector pins need to be 120 thousandths taller than the outer ones. All right, so we got our 2 sets of new ejector pins with our shoulder on it, and it's time to reassemble this mold without our kludgy spacers. But I'm sure I'll need these in the future. Okay, so basically what we need to do is stick the top of our ejector plate back on, and see, this pile is the taller pile, so these taller pins go into the middle, but here they are just about perfect. I don't know if this last one will hammer in home. Let's see if we can. There it is. Talk about precision. Okay, and then we'll put our outer set of ejector pins in the outer ring of this part. And then we put our bottom plate on. And I can see the original witness marks barely in this sanded surface, which is this orientation. And in a production mold, I would have machined pockets for the ejector pin feet to reside in so that these 2 plates are flush. But again, this is a one-off. See how our pins are sticking out there? Now when I pull this ejector plate back, you should see that they all become flush, like so. Now what I'm going to do is set this guy down, and the bottom of the ejector plate should basically make contact with the bottom of the mold perfectly. And it seems like it is. Yeah. Okay, that looks pretty good. Let's head back over to the molding machine now. All right, so we're back in the clean room, and I actually have another mold running on the 35-ton machine, which is one similar to that we ran before. You're gonna hear the air cylinder pop every now and then, and there's a stepper motor that's unscrewing parts. Right now I've got this ejecting without the robot assistance, without Orange's assistance up there. But once I get green running with its operation, then we will also probably have Orange start plucking parts as well. I can basically string this guy back on. I'll try not to block your view too much. There we go. So, may not be too bad. Now I'm going to bring the clamp forward, making sure nothing crashes. It looks like this toe clamp here is going to be a problem. And the rest of the hardware is passing. So there we clamped up on the mold in setup mode, so it's a lower pressure. Now we're just going to reapply our mold clamps. Checking here for smoke or any other things after we turn the heaters on. This is a temperature sensor for both heaters, so we're gonna cheat a little bit and have one sensor. Okay, so we want to make sure that we've got the ejector new position set. So I'm going to go to setup mode on the molding machine, and we will tell it to pull back on the ejector and set 0. Now what we're going to do is set the mold height, because we did remove that 1/8" spacer. So I'm going to close the mold. There, it seems like it closes to what I remembered it being. So we're going to hit it again, and then I'm going to tell it to set this new mold height. And now we will open the mold again. So semi-automatic, and then we'll hit the start. All right. We injected to 3.6 millimeters, or about 1/8 of an inch of cushion remaining in the plastic. Now we're loading the next shot, and we will open and see how we eject. Yay! So there we go. And our ejector pin heights look good. Let me see if we can zoom in on it. And there we go. So this is our first part after we fixed our ejector pins, and it's looking good. It ejected nicely. Now there is probably some leftover mold release in here from when we pulled the stuck part out, and just from, you know, the lubrication of the ejector pins as we put them in. So let's keep shooting some more and see how we're looking. Okay, I'm gonna hit the start button again. And this still is in semi-automatic mode, so we're gonna shoot one part. And we had a cushion of 3.8 millimeters. Oh, actually it didn't fill all the way. Okay, so we got down to about 4 millimeters as far as the amount of plastic injected. So if we go to the plastic injection, I had 3 millimeters as a cushion. So what I'm going to do is reduce the amount of plastic that we fill the injection unit with to 62 instead of 64. And now we will fill with a shorter shot of plastic. And then I'm going to manually open the mold up. So now we're going to manually open the mold. And I'm going to manually eject the part by hitting the eject button on the screen. Just like that. Okay. So now let's run this again and see if we get a full cycle. Now we're filling down to, it says 3.4, but I think it bounced back a little bit. Yeah, so now we're in the pack and we're filling the injection unit with more plastic. We're chilling a little bit and we're opening the mold and ejecting. Okay, I think we are set. Let me do that again. I'm gonna change the battery on this camera soon. Oh, it's looking like we're running pretty good here. Let's see if I can get this. The camera plus the eject action, or the molding machine control screen and the eject action. So you can see how the auger is pushing. We're in the packing phase. And there's an amount of time, and now we're filling. And we're cooling in the mold. Now we're opening the mold. Now we're ejecting the part. Now we're starting over again. Okay, so we are going to update the eject travel to something more like maybe 17 millimeters. And then we'll see if the part stays stuck in the mold when we eject. And then shortly thereafter, we're going to start fine-tuning the claw on the robot to pull it out and then clip off the runner from the part over here. Nope, that was still too much travel. So let's try 15. These parts are still usable. Okay, so that part stayed in there. So I'm going to open the gate and we'll see how easily we can pull it out. It's still a little too much. So I think our ejector travel needs to be 14 millimeters. Okay, so now I'm going to start the robot in teach mode. So it's going to come down here and try to grab that part. And we'll see how well my anticipated positions are. Oh, here it's waiting for me to, so this is where it'd wait for the signal from the molding machine, that it's all clear to use, or to go ahead and reach down. But I'm gonna skip that portion because we don't have it started yet. All right, here we go. Coming in a little hot. Okay. There we grabbed the part and pulled it out. Oh, that's not too bad. Actually, it had a little bit of a prying action in there too. So at this point, we would send an output back to the molding machine. It probably like right there. That says, go ahead and mold your next part. So I need to remember point 60. Around. I think I'll zoom in on this for you. Okay. And I usually do another wait after the cut to let parts fall away before the robot pulls stuff out. And it should cut pretty soon. There we go. Okay, so the robot still has the sprue in its hand, so its next step is to get rid of the sprue in a waste bucket that will be there. And then finally it will move back to the home position. All right, so I got the robot running here, and automatic mode, kind of checking out how everything's working. I got my hands on the emergency stops. So the robot's telling the molding machine to close. It comes over here and tries to clip the part off. But I think I need to refine the clip a little bit. It's not quite clipping in the right spot. And it's really how repeatable the robot grabs the sprue and the part determines how well the gate lines up with the cutter here. So let's see how it looks. See, that time it didn't. I'm just holding down the play button right now. And obviously it moves slower in teach mode so that things don't get out of hand with you. Or you can respond or react with the panic bar on the back. I also have a couple of unnecessary motions, but it's not worth fussing over getting rid of those. Okay, so now it's going to come into the clipper. Let's zoom in on this. Okay, so let's move in a little more. All right. Touch up, yes. Now I'm going to continue to play through the sequence with this updated point in teach mode. So I'm going to hit the play button and it should clip. There it went. Actually, so the magnet mount lifted up a little bit, which it's kind of designed to do. That way it can deal with kind of random forces without causing problems. It's kind of a dynamic mount. I'm going to hit the semi-automatic button. And this green light, if you can see it, means that the molding machine is waiting for the robot to tell it to go. So it should happen now. So right now I've kicked the robot back to 30% speed, and this is wasted time right now. So ultimately we're going to be running at 50%. But let's see how our clip goes. There we go. Oh, look at that problem. Oh, that's something I didn't anticipate. It clipped it, but the part laid onto the end effector of the robot. So isn't that wonderful? I may have to do an additional motion here to rotate the end effector. Oh, there it didn't do it. So let's go to 50% and we'll see how that looks. So this is half the program speed, which I'm probably going to leave it at this. Yeah, and this cutter still pulls a little bit, but maybe that's not a problem. All right, I'm gonna. Yeah, the part winds up sitting like that. So we can kill two birds with one stone, as they say. So I'm gonna do a motion here. I gotta figure out. Yeah, so this angle. Okay, so we're gonna angle like this. And we're gonna angle like that. Yeah, so I'm gonna teach this point. All right, I'm gonna see if we can just move the robot up a little bit to clear the molding machine door. And then we're gonna have it accelerate out of there. All right, so we're back. Even with our updated robot end effector tilt action, our part is just staying stuck in that little nook that we create. And I think the edge of the plastic part is actually getting hooked onto the remnant of the sprue, and like 30% of the time it cuts. So you can see we got our bucket here, and then here's our cutter itself. Let me zoom in on it. Okay, that one fell out good. It's actually Quinn from Blondie Hacks made that end effector for me about half a year ago. So if you want to check out her show, you can see how she made these aluminum cubes on the end of the robot. Well, now they're all working. So let's get a view of the pluck from the mold. So you see the little gripper on the bottom is the one we're using. Okay, we are in business. So the key is to time the robot cycle to be basically the same amount of time as the molding machine. If you have the robot going faster than the molding machine, then it's just lost wear and tear on your robot. But if you got the robot going slower than the molding machine, then your price per part goes up because it's all about the time it takes to mold the parts and a little bit for the material cost. So getting them synced up just right is best. And you'll see we've only got like 1.5 seconds between the signal before the robot's waiting on the molding machine. So that's good enough. Well, thanks for watching this week. Next week, I'm not sure what we're going to do. Now, there's one of those parts that hung up. But we may do some airline that we need to do in the shop. Also, a new small white robot showed up in a crate, so we can uncrate that. Not sure yet. But thanks for watching. Please like and subscribe to the show if you want to see more. And I'll see you next week. Have a good week. Bye.